Next topic, current in a straight long wire, chapter number 10. If we consider a long straight wire, suppose this is a long straight wire carrying current I. This is a long straight wire carrying current I of length suppose L. And due to that current, the magnetic field produced around this wire. Let a point P, and perpendicular distance R from the wire. Also we consider a small length element dl at a distance small r from point P. Suppose this is the center of that length element, and this small length element at a distance small r from point P, and this point P at perpendicular distance capital R from the wire. And suppose the L is the length of wire, and suppose this angle is theta. Then we find out the total magnetic field produced at point P. तर P या ठिकाणी किती magnetic field तयार होईल. Due to this perpendicular distance, the wire is cut into two half part, upper part and lower part. Then we calculate the magnetic induction at upper part and lower part. In figure, we consider the point P, and suppose B is the total magnetic induction at point P. Then according to Biot-Savart law, dB bar is equal to mu 0 upon 4 pi I dl sin theta divided by r square. This is the Biot-Savart law. That means this magnetic field at point P. But due to this perpendicular distance, the wire has two half part. Due to upper half part of wire, the dB is the magnetic induction produced, and the limit of integration will be 0 to infinity, because this wire is long, straight, infinitely long, hence integration will be 0 to infinity. And second, due to lower part of wire, and dB is the magnetic induction. Then total magnetic induction B is equal to this part plus this part, that is 2 integration 0 to infinity dt. This is the total magnetic induction at point P due to electric current I. Using this value, we can write 2 integration 0 to infinity mu 0 upon 4 pi I dl sin theta divided by r square. Therefore, B is equal to 2 is constant, mu 0 is also constant, I constant, 4 pi is also constant. Therefore, 2 I mu 0 divided by 4 pi integration 0 to infinity dl sin theta divided by r square, or B is equal to 2 mu 0 I divided by 2 pi integration 0 to infinity dl sin theta divided by r square. But in figure, sin theta is equal to pi minus theta, or is equal to, in figure, this is the right angle triangle. The value of sin theta, or r, capital R upon small r. Also, we find out value of this small r. The value of small r is nothing but, using Pythagoras in this triangle, we get r square is equal to L square plus capital R square, and value of small r is equal to under root L square plus R square. Put this value, suppose this is equation number 1, B is equal to mu 0 I upon 2 pi 0 to infinity integration dl sin theta divided by r square, equation number 1. Put value of sin theta, that is r upon r. Also value of r is under root L square upon r square. Then we get the equation B is equal to mu 0 I upon 2 pi integration 0 to infinity dl, as it is dl sin theta r upon r, but value of r under root L square plus r square into r square, that means L square plus r square, L square plus r square. We simplify this equation, we get B is equal to, this r is also constant, mu 0 I r divided by 2 pi 0 to infinity dl divided by L square plus r square raised to 3. Now again in figure, the value of L and value of dl will be, the value of L is equal to r, and theta is in trigonometry in figure, and value of dl is nothing but r sec square theta into d theta. Put these values in above equation, we get d is equal to, or also if change L is equal to r tan theta, dl is equal to r sec square theta into d theta, limit is also changed. Because theta is equal to 0, then, or L is equal to 0, that is, there is no length, the theta is equal to 0. If L is equal to infinity, then tan infinity, or this is nothing but in tan infinity, the theta is equal to pi. That means limit changes 0 to pi. Limit also changes 0 to pi. Therefore, b is equal to mu 0 I r upon 2 pi, as it is. Integration changes 0 to pi by 2. dl, instead of dl we can write capital R sec square theta into d theta divided by L r square tan square theta plus r square raised to 3 by 2. Therefore, b is equal to mu 0 I r upon 2 pi 0 to pi by 2 r sec square theta d theta divided by r cube into bracket tan square theta plus 1 raised to 3 by 2, which is equal to mu 0 I r into r divided by r cube 0 to pi by 2 sec square theta d theta divided by tan square theta plus 1 raised to 3 by 2. R square, sorry, there is 2 pi. B is equal to mu 0 I divided by 2 pi r, 0 to pi by 2. 2 r, 1 are remaining. These 2 cancel with these 2, 1 remaining. Therefore, B is equal to mu 0 I divided by 2 pi r. We solve this. X square theta into d theta divided by tan square theta, that is sin square theta divided by cos square theta plus 1 raised to 3 by 2. Again we simplify. We get B is equal to mu 0 r upon 2 pi r 0 to pi by 2 sec square theta d theta divided by sin square theta plus cos square theta divided by cos square theta raised to 3 by 2. Therefore, V is equal to mu 0 I upon 2 pi r 0 to pi by 2 cos square theta raised to 3 by 2 into sec square theta d theta divided by sin square theta plus cos square theta raised to 3 by 2. Or V is equal to mu 0 I upon 2 pi r 0 to pi by 2. This cos theta raised to 3. Sec square is converted into cos, that is cos theta square. Sin square theta, cos square theta 1, hence d theta. V is equal to mu 0 I upon 2 pi r integration 0 to pi by 2 cos theta 1 remaining cos theta into d theta. Therefore, finally B is equal to, that is magnetic induction at point P is equal to mu 0 I divided by 2 pi r 0 to, or this integration will be sin theta 0 to pi. B is equal to mu 0 I 2 pi r sin pi by 2 minus sin 0. B is equal to mu 0 I upon 2 pi r sin pi by 2 1 minus sin 0 0, or we get finally B is equal to mu 0 I divided by 2 pi r. This is the total magnetic induction at point P produced around the wire, and that wire is long straight wire.